So very quickly for review, if I were to show you a problem that was, I should just pick one, right? Oh, that's Wade. Sorry, I'm talking to myself. I had it. All right, here, it's back here. All right. All right, if I have N2O gas plus O2 gas, oops, 3NO. Although actually this probably is. And let's just say, there's one of those that is going to be different than the others. Can anybody find the one that will be different? What's going to be the change in enthalpy for oxygen? Yes. What? Yeah, no, it's not. We we're going to need some combination of yeah. What did we come up with?
A 2 in front of the N2, and then 4 in front of the N.
Yep, there we go. Thank you. All right, now, what do we have here? It's going to be, if we want to know, this question is asking us, what's the change in enthalpy for this chemical reaction? And your book may have not written these in the problem. The assumption is that you have a chart in your book or you have an appendix where you can go. But for here, I've given the standard enthalpies for our NO and for our N2O, and our oxygen we've decided is 0 because the standard enthalpies for all the elements in their standard state, oxygen is a gas at room temperature, and so that's a correct assumption. Now, we're going to start with our product, so we're going to take 4 times 91.3 kilojoules per mole. Our oxygen is going to be 0, so we're going to have minus 2 times 82.6 kilojoules per mole. Alrighty, so now in order to solve, and this is a problem that is the type of problem that you should have done in a previous chemistry class. So, 4 times 91.3 is 365 kilojoules per mole. 82.6 times 2 is 165.2 kilojoules per mole. If we 200 kilojoules per mole. And so after we're all done with this, we can say that this is an endothermic. Remember, if we have a positive enthalpy, that means it's endothermic. If it's negative, we have an exothermic reaction. We talked about that when we did Le Chatelier's principle. So hopefully you got caught up on that. The only thing I wanted to show you is that these are key. These standard enthalpies of formation are for 1 mole, and so that's why we have to take into account the molar, the coefficients in front. If we had additional reactants or products, we would also have to take them into account as well. Right? Does everybody remember having to do that? I sometimes, if I have more than 1 reactant, like to put this part in brackets. This reminds me to completely evaluate this part of it, because this subtraction sign sometimes goofs people up. They'll subtract the first reactant and add the next reactant, which is not what you want to do. Alrighty, your standard enthalpies are in an appendix. They're on page A5. There's also a page number where they appear that's in chapter 6. That page number is 274. So you may have to look up your standard enthalpies, and they may not be in chapter 17. One more time, just to make sure we've covered all our bases. If we have an exothermic reaction, our standard change in enthalpy is negative. That means heat is released. If we have an endothermic reaction, that means that our standard enthalpy change is positive and heat is absorbed. Okay? All right, so far so good. Entropy is the measure of randomness or disorder in a system. We've already talked about that. What that might mean, we're going to talk a little bit about specific chemical reactions in a little bit. And it turns out that we will calculate an entropy change for a chemical reaction in just the same way. If we have a standard, if we have a chemical reaction and we want to find out what the entropy change is, we can look in the appendix. We can calculate the entropy of the products times their coefficients and subtract the reactants. The only thing that's going to be different is that all the standard entropies for individual molecules will be positive, right? Now, students sometimes get confused because they think you can't have, that means you can't have a negative standard enthalpy for a chemical change, but that's not true. You can have, all you have to do is have these reactants be larger, okay? So the change